Hello everybody, welcome to chapter 4.1, Linear Equations with Fractions. In this particular chapter, we're going to look at equations that involve fractions. For example, in example 1, we have a situation where we have fractions here and they both have the same number in the denominator. So let us go over to the whiteboard and see how we would solve for z. Let's look at example number 1. And example number 1 is z minus 2 over 5 is equal to 8 over 5. Now, one way to look at this is we can put the 2 over 5 and on the same side as the 8 over 5. So that will give us z is equal to positive 2 over 5 plus 8 over 5. Now notice that the denominators here are the same. So that means we can add up the numerators and get 8 plus 2 is 10. And then, of course, the denominator that's common or the same is 5, and we get 10 over 5, and that is equal to 2. So this means that z is equal to 2. So that is one way to do that. Another way to do it is a technique which is more powerful and more useful is by clearing the denominator. Now you may ask, how do we do that? Well, let's look at what we have here. And we have z minus 2 over 5 is equal to 8 over 5. Well, z is really over 1. So that means we can look at all these bottom parts or denominators and look for what is essentially the lowest common denominator and use that to get rid of the fraction. So the lowest common denominator here is equal to 5, which is the same thing as 5 over 1. So what we're going to do is we're going to multiply everything through by 5 over 1. So here I go 5 over 1 times z over 1 minus 5 over 1 times 2 over 5 is equal to 5 over 1 times 8 over 5. And then I see that here, okay, 5z minus, well, the 5's cancel out here. So that means I'll just get a 2 here. And this is here. I get the 5's to cancel out. And that means I get an 8 here. Then I do my algebra, plus 2, and this implies that I get 5z is equal to 10, and then I divide by 5 on both sides, and that means z is equal to 2. So for this particular example, this way would probably be the easier way or the quicker way, but we could also do it this way, which is a more general way to do it. Now let us review what we just did on the whiteboard. The easiest way to solve this is to recognize that the denominators are the same in the fractions here. So both of them have 5 in the denominators. So that means we can take this one and bring this one over and get z is equal to 8 over 5 plus 2 over 5, and this implies z is equal to 10 over 5, or 2. Another way to do this is to clear the denominator. This means that we multiply everything by 5 here. So what I did was I took everything and I put it 5 over 1, because that's essentially multiplying it by 5, so we don't confuse things in the fractions. And then I redid the equation by canceling out the 5's here, the 5's here, and that gives us the equation 5z minus 2 is equal to 8. So notice how the fraction goes away, and we can solve like a regular algebraic equation using this particular technique called clearing the denominator. And we find, as before, 5z is equal to 10, and then we divide by 5 on both sides in order to get z is equal to 2, just like we did using the previous technique. In example number 2, we want to solve for w. So let us go over to the whiteboard and see how we could solve for w. Now we're going to look at example number 2. And as before, there are actually two main methods you could use. One of them is a much quicker method that works for this particular type of problem, and the other one is clearing the denominator like we did in the previous problem. So let's look at the first method, which is called the ratio method, and you'll see why it's called that in a minute. So my problem is, or my example is, 15 is negative 5 over 8w. Well, I can rewrite that as 15 over 1 is equal to negative 5w over 8. And so what I created here is a ratio. This is a ratio and this is a ratio. So that means that I could cross multiply because I have the equal sign here, and that means that I would get 8 times 15 is equal to negative 5 times 1w. So there, 8 times 15 is 120. And that's equal to negative 5w. And then I just solve for w and find that w is equal to negative 24. Now, of course, you can go back and check it if you would like. Now, the other method that I showed you in the earlier problem was clearing the denominator. And to clear the denominator, we want to find the lowest common denominator in this. So we will rewrite it the same way we did here. 15 over 1 is equal to negative 5w over 8. And we can see that the lowest common denominator is equal to 8. And we'll put a 1 as a place marker so that we're very clear when we start clearing the denominator. So now I take this 8 over 1 and I multiply it through by everything. So I have 8 over 1 times 15 over 1 is equal to 8 over 1 times negative 5w over 8. And now I see that, well, both of these are over 1, so 1 times 1, there's no canceling. So that's 8 times 15 is equal to, but I see that there's an 8 on the top here and an 8 on the bottom there, and that means I can cancel. So that means I end up with negative 5w on that side, and that means we get 120 is equal to negative 5w, and then continue with the algebra. And we find that W again is equal to negative 24, just like we found there. Let us review what we did on the whiteboard. We can use what is called the ratio method. This means we can cross multiply and solve for W. So what I did was I set it up as a ratio and then turned it into a regular algebraic problem and solved for W and found that W was equal to negative 24. We can also clear the denominator by multiplying the whole thing through by 8 and then solving for W. So I put 8 over 1 to make it clear about the fraction so that I know where to cancel out. And I turned it into a regular algebraic problem, and then I found that W was equal to negative 24 as before. In example number 3, we're asked to solve 2x minus 1 is equal to 3/4 x plus 9. Now let us go over to the whiteboard and see how we would tackle this type of problem. In example number 3, we have a situation where we have 2x minus 1 is equal to 3 over 4 x plus 9. So one way to look at it is we can put all the x's on one side and all the numbers on the other side. So let's do that. So we have 2x minus 3 over 4 x is equal to 1 plus 9. So what we can do is we can combine the x's, and that's one way of looking at it. If you know that 2x and you know what denominator put there, we could do that. So we could say that 8x over 4 minus 3 over 4 x is equal to 10. So that means we can subtract and get 5x over 4 is equal to 10. And then we can apply the ratio method. And we end up with 5x is equal to 40. And then we can divide by 5, and find that x is equal to 8. And yes, that is definitely one way to do it. But again, as I said, by clearing the denominator, you can avoid all this fraction stuff. So let's do it by clearing the denominator. Well, we have 2x minus 1 is equal to 3 over 4x plus 9. And we'll see the lowest common, so I'll put a 1 here, a 1 here, and a 1 here. And we find the lowest common denominator is equal to 4. So now I will multiply through everything by 4 over 1. So I have 4 over 1, 2x over 1 minus 4 over 1, 1 over 1 is equal to 4 over 1, 3 over 4x, and then plus 4 over 1, 9 over 1. So here I have 8x minus 4 is equal to, my 4's cancel out here, so I end up with 3x plus 36, because 4 times 9 is 36. And then I go through the algebra, putting something, so here I get plus 4, and I end up with 8x is equal to 3x plus 40. minus 3x minus 3x. And here I get 5x is equal to 40. And then I divide by 5, and I get, as before, x is equal to 8. So here, and by using this clearing the denominator, I can simplify and get rid of all the fraction nastiness and make it into a simple algebraic problem. But of course, whatever methods you like to use is fine, but certainly clearing the denominator is a more powerful method. In reviewing what we did on the whiteboard in example number 3, we used the technique of clearing the denominator, and we did this by multiplying everything through by 4 and then solving for x. So what I did is I set it up so that 4 over 1 is 4, so that it is in a form that will clear the denominator, and then I turned it into a regular algebraic equation, and I solved for x and found that x was equal to 8. In example number 4, we want to solve for m in this particular equation, where 3m over 2 plus 1 is equal to m plus 9 over 2. So let us go over to the whiteboard and see how we would do this particular example. In this example, example 4, I'm just going to use the technique of clearing the denominator. So I start out with 3m over 2 plus 1 is equal to m plus 9 over 2. And what I'm going to do, I'll just put a 1 here and a 1 here to make everything very, very clear, that I see very clearly my lowest common denominator is 2, and I'll just put a 2 over 1 to keep things tidy and clear. And so I'll multiply through the whole thing by 2 over 1. So I have 2 over 1 times 3m over 2 plus 2 over 1 times 1 over 1 is equal to 2 over 1 m over 1 plus 2 over 1 9 over 2. Now I'm going to get rid of all those fractions, meaning clearing the denominator, and I see I have a 2 on the bottom here and a 2 on the top there, and they cancel out to make 1, so I have 3m, and I'm not going to write over 1 because I want to make clear that I made everything clear the denominator and got rid of the messy fractions. Here I have just 1, so that's just plus 2. And here I have 2m plus, and I see again the 2's cancel out, so I end up with 9. Now I'm just going to treat this as a regular algebra problem, and I'll have minus 2, minus 2. So here I have 3m is equal to 2m plus 7, and then minus 2m on this side, minus 2m on this side, and that means that m is equal to 7. In reviewing what we did on the whiteboard, again, I used the technique of clearing the denominator. Here, I multiplied by 2 and then solved for x. So here is what I did. I put 2 over 1, so it's clear on how I do my cancellations, so that I made an algebraic equation, and I found that m was equal to 7. In example 5, I'm asked to solve for u in this particular equation. So let us go over to the whiteboard and see how we would do this. And finally, we're going to look at example number 5. And in example number 5, we have u over 4 plus 1 over 12 is equal to u over 3 minus 1 over 6. So as you see, this is just a nasty, nasty fractional situation. So what we want to do is we want to find the lowest common denominator, and as before, we're going to clear the fraction so we don't have all that nastiness to deal with. So we look at this and we see that the lowest common denominator here is 12 because everything goes into 12. 4 goes into 12, 12 goes into 12, 3 goes into 12, and 6 goes into 12. So that's why it's the lowest common denominator. And I'll put it over 1 so it makes it nice and tidy that we can follow along and know exactly where cancellation is happening. So I proceed to do it. 12 over 1 times u over 4 plus 12 over 1 times 1 over 12 is equal to 12 over 1 times u over 3 minus 12 over 1 times 1 over 6. And notice how I'm multiplying through every single one of these terms by 12 over 1. So let's look at this first term. Well, I see 4 goes into 12 3 times. So I get 3u. And then I look at the next term and I see the 12 and the 12. Well, they cancel out to give me 1. So essentially that's just 1 times 1. And then my next term, I have 3 goes into 12 4 times. So that'll give me 4u. And then I have my term here. 6 goes into 12 2 times, and 2 times 1 gives me 2. So now I have a nice, easy algebraic formula or algebraic problem to deal with. So I end up with 3u plus 1 is equal to 4u minus 2. So what I'll do is I'll go minus 3u minus 3u. So that will give me 1 is equal to u minus 2, and then plus 2, and then plus 2. And that 1 plus 2 is 3, and u. So my final answer is u is equal to 3. In reviewing what we did on the whiteboard, we found that we must find the lowest common denominator before we can clear the denominator, because notice how all these denominators are different. The lowest common denominator we found is 12, since all the denominators divide into 12 as whole numbers. And then we use 12 over 1 to clear the denominator and make it into a regular algebraic equation and solve for u, and we found that u is equal to 3. Thank you very much. Be well and take care, and goodbye for now.